Moving on. Alrighty, so we just went over I just went over all of this stuff and figured out that it's figuring out the x, y, width, and height that after scaling for the bounding box on something. So now I'm going to go up to here. We have keep dash indexed. I think this is, since it's a built-in and since this lambda here takes a index and an item, that what this does is call this with, yeah, it looks like it's going to call it with this list right here. So the idea here is we're going to make a function or a lambda that takes in index and item, and then find the scaled x, y, width, and height of that text item. Alrighty, so yeah, that's what all of this stuff does. Oh, no. Okay, and it returns this data structure right here if the mouse is hovering over it. Okay, find the scale and determine it when the mouse is over the bounding rectangle, then return info about that rectangle. Okay, so we need to find out which rectangle the mouse is over, and the way we do it is by going over every single rectangle and figuring out every single text item and figuring out which, if the mouse is over it, and saving only the ones where the mouse is over it. That's what all of this does. And then we bind whatever that is to this text hit right here. So we're grabbing the first one out of all of the ones where the mouse is hovering over it. I don't know if I'll be able to find, let's see, what is the data structure that ends up getting returned? So we have, I don't know if I'll be able to write this whole thing from scratch. So we have a data structure, a map that has type, index, and item. I feel like if I know that, then that should be enough to create that. Let's find out. What am I going to try to do? First, I'll try to do just this lambda right here. So I'll bring all of the comments out, and then I'll get rid of the lambda and see if I can recreate it. So index and item, I think. It was just there, and I already am not sure. X is going to be multiply the scale by get the X part of the item, and then we have Y is going to be multiply by the scale the result of subtracting from the page height the Y part of the item. That's the X and the Y, and then the width is going to be multiplied by the scale, the width of the item. I'm actually not sure. Do items have a W or a width? Item. Let's see if I can recreate it without referring back. Okay, so they have a height, so they probably also have a width. Yeah, they have a width. Okay, cool. And it looks like this same exact calculation is done elsewhere, so that seems like grounds for making a function. I also think that maybe instead of x, y, width, and height, it should be like left, right, top, and bottom. That's probably going to be better. Okay, so let me go back to here. We got x, y, width, and height, and that's going to be multiplied by the scale, the height of the item. And once we've done all that, then we check when mouse, no, what was it? Point in rect, I think. Point in rect, yeah. Point in rect, mouse X, mouse Y, X, Y with height. When that is true, then we resolve to the type is text, the, what is the next one? Index is index, and the item is item. Alrighty, did that work? Do I still have the page open? It looks like I do. Let's go bring that up. Refresh. Okay, can hover my mouse over stuff and click on stuff. Oh, uh-oh. No, okay, it didn't work. So I messed up something. When I click on a label, it doesn't let me then click on a text item to associate it. So, and I was just modifying the code that finds the text item. So this code right here is wrong. Let's see if I can figure out why by staring at it. We scale all the things and we subtract the page height. Maybe this should be the other way around. We take the page height and then do the scaling. But I don't think so. There was that other place where the same calculation was done. So let's go to there. So we have subtract from page height y2. This is for a field, not an item. Okay, here we have scale the page height. Oh, we want to subtract the y and the height right. We're flipping the direction. We're translating by page height, and we need to give the other side of the box. So if y is the bottom of the box, and then adding height gets us to the top of the box, we want to get to whatever the other side of the box is. Maybe y is the bottom and we want to get the top of the box, and we should store that in this y, or in this y, or maybe it's the other way around. Maybe y is the top and adding height goes down towards the bottom. Either way, whatever this y is here of this item, we want the other side of it to be stored here. We want the other side of the item to be stored in this value here. Which makes sense if you think about, like, if you're flipping the y-axis going from top to bottom, the thing that you would encounter first going from the top towards the box would be the top of the box. And if you're at the bottom of the page and you go towards the box, the thing that you would encounter first would be the bottom of the box. So we want to flip the direction of the y-axis, translate by this amount, and we'll encounter the other side of the box first. So yeah, let me go back up here, and that means this calculation here, we need to get the height of the item, and then this whole thing is going to, I'll format it a little bit differently, and we'll try saving that. And now let's go back to the web page, see if that worked. It looks like it's working. If I click, yeah, it's working. Okay, cool. Not sure what happened there. I think I clicked maybe just outside of the bounding box. The green box didn't come up for a second, and I had to click it twice. But, okay, so I'm able to recreate this whole section of the code. Well, I guess I didn't recreate it. I almost recreated it, and then I had to go reference some other part of the code. But I won't try retyping it out. I'm satisfied that I could do it. Okay, so then we're going to call keep indexed on that function and the items. Yeah, items. Cool. We're going to use the keep function, and oh, I guess that's all 10 minutes. Wow, that was fast. All right.